Pieces of fabric for costumes are shaped as an obtuse triangle as shown. You cut a parallelogram to make two of the triangles. Which diagram shows an original parallelogram fabric piece? What is the area of each triangular piece?
Which diagram shows an original parallelogram fabric piece? The first one you would eliminate is B, because B is not a parallelogram. The second one you eliminate is A, because if you can tell right here in the model, 89 and 22 are perpendicular, which is forming a right angle, which is also 90 degrees. And if you see right here, they moved 89 to the other side, which you cannot do that. And 89 and 22 are not perpendicular to each other, and they're not forming a right angle. So the answer would be C.
Because
As you can see, 22 and 89 are perpendicular to each other, and they're forming a right angle.
And you make a copy and you rotate it, and 46 is connected to 46. So that one.
You will choose C.
Yes, is the best answer. Now we need to find the area of the triangle. So we need to start with our formula. So go ahead and start with the formula. Substitute and evaluate.
We'll start with your formula, which is area equals 1/2 times base times height. And then you would substitute for your base. And your base is 89 centimeters. And your height is 22 centimeters. So you would find 89 times 22, and you will get 1,958, and you will have to divide that by 2, which is also the same as multiplying by 1/2. And your answer will be 979 centimeters. So that will be what you will put here.
And that's it. Thank you.
Janice is mailing a package shaped like a rectangle, which I'm shown in the figure. Use a net to find the surface area of the package.
So what's the first thing we have to do? Raise your hand.
You have to draw the net.
We have to draw a net. So when we draw the net, we want to draw the base first. So I'm going to draw my base. And if I outline the base right here, this is my base. And what are the dimensions of my base? One person. Yes.
5 and 5/10 times 6. Well, 6.
And 6 centimeters. So exactly. So I have my base. And then I need to draw a lateral face that's connected to that. So I'm going to draw the right face, which is going to go right here. And then I'm going to outline it, which is right here, so in orange. And what are the dimensions of my right face? Yeah.
2 and 8/10 centimeters. And 6 centimeters.
And 6 centimeters. And then I'm going to draw my top face right here, which is 5 and 5/10. And it's going to be the same as this one right here. So they have the same.
Because they're parallel.
Yes, because they are parallel. And then I have to draw the other one. So it's going to be the same as this. Now I need to draw my front and my back face. So what are the dimensions of my front face? If I outline it right here, I can see what my pen is going across. And what is that? The blue. Yeah. The blue. It'll be, yeah.
5 and 5/10.
5 and 5/10 by what?
2 and 8/10.
Exactly. And notice that it has to connect to this part right here. So they have to have the same length. Because a net means to fold it in, and it's going to fold into that shape perfectly. And then we have another one right here, a back face. with the same exact area. So we just need to find the area of one, and then we can add it all together. So I have my left and right. I have to multiply. So since the area of a rectangle is equal to base times height, I need to use this formula for all of these, right? So I'm going to do the first one first, my left and right face. So I have to multiply 2 8/10 times 6, because since this is a rectangle, 2 8/10 times 6 is 16 8/10. So that's going to be the area. That's how many square units is inside of the left face. And since my left face and my right face are perpendicular to each other and they have the same base and height, they're going to have the exact same area. They're going to take up the same amount of space. Now I need to find my area of my front and back face. Right?
Right.
So I have to multiply 5 5/10 by 2 8/10 because that's a rectangle. And once I multiply 5 5/10 by 2 8/10, I end up with 15 4/10 centimeters squared. And since my front face has the same exact dimensions of my back face, I know they're going to have the same exact area. Now what do I have to do? Yes.
Now you have to add all of them up.
Add all of what up?
Yeah.
How many faces does this figure have?
4, 6.
6. Look at the neck. 1, 2, 3, 4, 5, 6. We're not finished doing something. What do we have to do?
You have to find the area of your base.
We have to find the area of the base. So how do we find the area of the base? We multiply the dimensions. How many square units the figure encloses. So we have to multiply 5 5/10 by what number? 6. And then we'll end up with the area of the base, which is 33 centimeters squared. Now we need to find the area of the top base, which is the exact same as the bottom base, because why are they exact same?
Because they take up the same amount of space.
They take up the same amount of space. Now we need to do what?
Add them all.
Add all of them. If you do not add the top base and the bottom base, then you're going to get the wrong answer. The surface area is going to be a lot smaller than what you would normally get. So we have to add 16 8/10 plus 16 8/10 plus 33 plus 33 plus 15 4/10 plus another 15 4/10. And once we add all of those, we'll have the surface area, which is the area of the surfaces. And once we add all of that, we'll end up with 130 4/10. Let's just make sure.
The surface area of the property.
So there's another way to find the surface area, the area of the surfaces of a three-dimensional figure, without drawing the net, even though it said draw the net, but they're concerned about the answer. So we're going to use it without the net. So the first thing I want to do is find the area of my base. So my base dimensions, so I need my base. My base is a rectangle, so I need to use the formula area equals base times height. So the base is going to be 6 by, I'm going to substitute 6 and 5 5/10 into that. And once I multiply that, I'll get the area of my base, which is 33. So the area of my base is 33, and since I have 2 of those, I can multiply by 2, but I'm going to wait. Now that I have the area of my base, I want to find the area of my left face. So if I outline my left face, I can get my dimensions, or my right face, left and right, same thing. So right face is a rectangle, so I'm going to draw a rectangle, and the formula is area equals base times height. And then I'm going to substitute what dimensions into this formula. Yes.
5.
Did my pen go across the 5?
2 8/10 times 6.
Times 6. These two lines are parallel to each other, so they take up the same
Same
the same length, right? So it's 2 8/10 times 6. And once you multiply that, you get 16 and 8/10. So that's going to be the area of my left and right face. Now I need to do one more face because I have another face. And which face is that? Yeah.
You have to do front and your back face.
Front and back face. Right? And since that shape is a rectangle, draw a rectangle, formula, area equals base times height. So this is going to be the front face. So what numbers am I going to substitute into this base and height? What two numbers am I going to substitute into the base and height? The purple, the base and the height.
You would have to substitute 5.5
5 and 5/10 and
and 2.8.
2 and 8/10 centimeters. And once we multiply that, we get 15 and 4/10. Now, can we just add all of these up? We have two of these. We have two of each one of these. So two things we can do. What's one thing? Yeah.
We can add 33 plus 33, 16.8 plus 16.8, 15.3 plus 15.
Yeah, exactly. So we can add each one of them twice. What's another thing?
Or you can just multiply each by 2 and then.
Or you can adding is the same as multiplication. Repeat it.
Is multiplication.
Thank you. Yes. Or we can do that. Or we can add them up and then multiply all of it by 2. Let's just do it this way. So times 2, we're going to have 66. And then we multiply this by 2, multiply this by 2. Or we could just write it out. Let's just write it out. So we have 33 plus 33 plus 16 and 8/10 plus 16 and 8/10 plus 15 and 4/10 plus 15 and 4/10. If we write it out, we can see that we're not missing any of our face. Versus we have to remember, oh, did I multiply by 2? So it may be better to just write it out. Then once we add all of that up, we should get the exact same answer that we had before, which was 130 and 4/10 centimeters squared, because area is 2-dimensional, so it's going to be centimeters times centimeters, so that's how you end up with centimeters squared. Name the figure shown, and what is the name of this figure?
The name of the figure is a hexagonal pyramid. I know this is a hexagonal pyramid because there's a cone sitting on top of a 6-side hexagon.
Good. How else do you know this is a hexagonal prism? I mean, a hexagonal pyramid. Yeah.
Because if you count the bases, the sides of the base, there are 6, so that's how you know it's a hexagon. And then there is a pyramid on top, so that's how you know it's a hexagon.
Okay, what else? Yeah.
Because the lateral face are made up of triangles.
The lateral face are made up of triangles. Anything else?
You know, this is a pyramid, not a prism, because only a pyramid has one base.
Pyramids only have one base. Good.